All right, week number 6. Here we go. Last week we talked about finding derivatives of tangent, e to the x, natural log, and all that kind of stuff. We talked about product rule, quotient rule. So we're really cruising really fast over derivatives. Okay. So a lot of students, they ask, "Oh, Caleb, where's your work on the last assessment?" Oh my goodness. I was having a difficult time trying to grade yours because I didn't see any work.
On the last one, oh shoot, I emailed it to my Waukesha email, but I forgot to then forward that to you.
Yeah, because
some of you, that to you, sorry.
Yeah, some of your answers do not look so hot.
Oh, okay.
And
For which ones?
And sometimes the way you write the problem down, the answer, for example, like this problem here, this is going to be, oops. This is going to be the quotient rule, right? So u is equal to e to the x, u prime is e to the x, and v is equal to x plus 4, v prime is equal to just 1. So inside minus outside, all over bottom.
Yeah.
Now that's how I would do my answer. Now if you multiply this all out and try to simplify, it could be different than what my answer is, but it just did not look right.
Okay, I'll forward you my work.
Okay, that would be great. All right, so this would be my answer for. Oh, I guess I won't find an equation of tangent. So here's my point. And then my slope, I'd have to use my equation. So if I put x in here, e to the 0, well, that's 1, right? Anything to the power of, so that's 1. And then if I put 0 in here, that's 4. Let's work it up here. That's 4 minus 1. So that's going to be 4 minus 1, which is 3 on top. And then on the bottom, if I put 0 in there, for x, I end up with 4. So my slope would be 3/4 here. So my equation, y minus 1/4 equals 3/4 x minus 0. And that would be my equation of a tangent line at that point. All right. Now the first problem, we kind of skipped over that one so far. In this one, u is equal to x minus 1. U prime is equal to 1. V is equal to e dx. V prime is equal to e dx. Inside, e dx plus outside. So that's going to be e dx x minus 1. If I put, this time my x value is 1. So if I put 1 in there, I'm going to end up with e plus e, 1 minus that 0. That's going to cross out. So I'm just left with e. So my slope would be e. My point is 1, 0. So y minus 0 is equal to e x minus 1. All right. Any questions on those two problems? Onward. It says use the quotient rule to find the derivative of the function. Okay. So Caleb, I want you to do the first one. I want to see where you're going.
Okay.
And I will do this. Good afternoon, Henry. How are you doing? it, I'm sitting here yapping away. So in this problem, very nice. So u is equal to x, u prime is equal to 1, v is equal to x minus 5, v prime is equal to just 1. So inside, so x minus 5, minus outside, so that's just x, all over bottom squared. Well, if I square the bottom, I just have negative x minus 5 squared, so that takes care of the x's, so negative 5 over x minus 5 quantity squared. I agree 100%, Caleb, very nice. Okay, and here's the second one. I worked out sine of x, cosine of x, e to the x, e to the x, inside minus outside, all over bottom squared. So the quotient rule should be fairly easy to use. Now this one, we did this one a couple times last week. If I wanted to find 1, 2, 3, 4, 5, 6, the sixth derivative, okay, so that's 1, 2, 3, 4, 5, and 6. Okay, so we start off sine. The first derivative is cosine. Then negative sine. Then negative cosine. Back to sine. Cosine. Negative sine. Should be my sixth derivative of the sine function. This week, we are going to do the chain rule, an introduction to the chain rule. Now, the chain rule is the most important. You guys already had calculus, so I'm just going to put a problem on the board, and I'm going to see how you do, okay? And it's not going to be an easy problem by any means, so I just want to see how you guys would do a problem like this. Let's see here. Let's do, all right. So what would your answer be to that problem? Now, if you understand how to do this problem, there's nothing that I'm going to be able to teach you in the chain rule that's gonna you're gonna not know. So, but I'm gonna kind of guess that neither of you are gonna get the right answer for this. Just a guess, not saying you're gonna get it wrong, but it is a tough problem because it is a chain rule inside a chain rule inside a chain rule. So let's see how you guys do. Give it a shot. All right, I don't see an answer yet. You guys can just say your answer if you want to. It doesn't matter. Probably easier than writing it down. Cosine of 3e to the x to the third times 9e to the x to the third. Okay. Henry, what did you get? 3 e to the cosine 3 e to the x. Okay. I probably wrote this problem in a really poor way. Would this make any difference? See, what I really wanted, yeah, this is what well, no, this is what I really wanted.
Okay, yeah, yeah.
Is that different than what I have? Yeah, see, I didn't, yeah, sorry about that. I wanted the sine raised to the third power. And now that I'm looking at it, I needed parentheses in there, or I needed to put it over here. Okay, because what I really wanted you guys to be able to, I wanted to see, if I had it written this way, then you should rewrite it something like this, all raised to the third power. So the highest exponent would be the 3 here. So you bring the 3 down. I'm going to write it down here. You leave the middle alone. And this would be to the second power. And then you take the derivative of the sine function, which would be cosine, leave the middle alone, times the derivative of the middle. So that would be a chain rule inside of a chain rule inside of a chain rule. Yeah, I kind of wrote it the wrong way. I did not want to write it. Darn it. Sorry about that. All right. So the chain rule just says that if you're differentiating a composite function like f of g of x, that is equal to f g of x times the derivative of g of x. So what you're doing is you're taking the derivative of the outside function, you're leaving the inside alone, and then you're taking the derivative of the inside. Well, this could happen 3, 4, 5 times in a problem. That, chain rule, I've seen chain rules where you have to go 4 or 5 derivatives out. As long as you understand how you're going from inside to outside. This is the rule. You work from the outside and you work toward the inside. So if I give you this is a very simplistic problem for chain rule. This is my inside function, this is my outside function. So the first thing you do is you bring the 2 down, you leave the middle alone. Times the derivative of the middle, which just happens to be just 3. So my answer would just be 6 times 3x plus 1. I could multiply it out if I wanted to. It really doesn't make a difference. They're not going to, those aren't the things that you're looking for. So what about this problem here? What would my answer be for this one? I've got the square root of 13x squared minus 5x plus 8. What is my answer for this one? And you guys can write it down on the board if you want to, if that's easier, or type it in chat box, or you can just say it. It makes no difference.
It would be 1/2 13x squared minus 5x plus 8 to the negative 1/2 power. And then that times 26x minus 5.
That sounds about right. It's kind of hard when I didn't have the answer written down. But if I was going to do this problem, the first thing I would do is I would just rewrite this as 13x squared minus 5x plus 8 to the 1/2 power. So now I've got a power, so I'm going to bring that down. So I've got 1/2, leave the middle alone, 13x squared minus 5x plus 8, all raised to the negative 1/2 power, times 26x minus 5. Is my answer correct the way I have it written? I disagree. This is not correct. And the reason is I need to have parentheses around here. Because if I don't have parentheses around there, basically what you're saying is you're multiplying this times 26x and then you're subtracting 5 off at the end. So there's a huge difference when you're taking the derivative of the inside. Make sure you put inside parentheses. That's always a safe bet to put it inside parentheses. Now I could rewrite this thing as 26x minus 5 over the square root of, and then I have a 2 on the bottom, and then I'd have 13x squared minus 5x plus 8. These are all different ways of rewriting the same problem. And that's where the multiple choice type of problems come in on the AP test is, they look for that. All right. So I'd like you guys to do these two problems. Now, you look at the first one, looks pretty easy, right? The second one, however, is a little bit tougher because you've got a quotient rule and the chain rule, right? So the first one, not bad. I just bring the 3 down, 2x minus 7 to second power times, this time it's just 2. This one, I have to use, well, I suppose I wouldn't. I suppose I wouldn't need to use the quotient rule here. And the reason I wouldn't need to use the quotient rule, because I could bring this up, could I? I could rewrite this as -3 t minus 2 to the -4th power. Oh, I didn't even think about that. I bring that baby up. Now it's a really easy problem. I just bring the 4 down, so that's going to be 12 t minus 2 to the -3rd power times 1. Yeah, that was way easier than I thought. Right? Do you guys see how you can start manipulating problems around to make them easier? I mean, I could have used quotient rule on here. It would have, would have been a little bit more difficult, but it wouldn't have been impossible. All right. I want you guys to do all 4 of these. Use the chain rule with trig function. So what is the derivative of sine of x? What is the derivative of sine of 3x? What is the derivative of sine of 3x squared? What is the derivative of sine squared of 4x? Okay. So what are the derivatives of every one of those? All right. Let's see here. I don't see an answer yet. Okay, cosine of x, 3 times the cosine of 3x, 6x cosine 3x squared, and 8 sine of 4x cosine of 4x. Okay, I've got to do that one. I can't do that one in my head. All right, so I agree. Sine of x, cosine of x. Second one, sine of 3x, so I take the derivative of the outside function, which is sine, so that's going to be cosine. Leave the middle alone, times the derivative of the middle, which is 3, so 3 cosine 3x. I agree with that. The third one, again, the sine is the outside function, so that's going to be cosine. Leave the middle alone, times the derivative of the middle, which is 6x. So that's going to be 6x cosine 3x squared. Then the last one, this one, I always tell kids to write it this way. Anytime you have a square here, it really means the same thing as this. Okay, so now I bring the 2 down, I leave the middle alone, times the derivative of the middle. Well, the derivative of sine of x is cosine, leave the middle alone, times the derivative of the middle, which is 4. So my answer would be 8 sine 4x cosine 4x. Now, do you have to multiply the 4 and the 2 together? No. If you had 2 sine 4x cosine 4x times 4, perfectly fine. It doesn't make any difference. It really does not. A lot of times we like to bring our numbers, multiply our numbers out, but it's not the end of the world if you don't. That is okay. So if I had a problem like cosine 3x to the fourth minus 2 with respect to x, it's an easy one. Negative sign. Oops, I better write out the whole thing. Negative sign, leave the middle alone, 3x to the fourth minus 2 times the derivative of the middle. Now I would put a multiplication there, so that would be 12x to the third. I guess I don't really need the parentheses in this one because it's only one term. Done. That is it. All right. Examples of repeated use of the chain rule. If I had something like the third root of sine of x squared, that, again, I would write this way. I would rewrite it as a sine of x squared, all raised, because this is the third root, to the 1/3 power. Bring the 1/3 in front, leave the middle alone. Oops, sorry about that. And then that is to the negative 2/3 power times the derivative of the middle. Well, the derivative of sine of x squared is cosine x squared times 2x. Oops, I have to do a times sign here. And that should be my derivative. So you can use the chain rule more than one time. You use the chain rule inside the chain rule inside a chain rule. Kind of gets interesting. All right. Now when we have the derivative of natural logs. Okay, so the derivative of natural log of x is 1 over x. Now that is when it is just an x there. If there's anything other than an x, okay, let's say it's a function, then the derivative of natural log is u prime over u. That's it. That's the whole derivative. So if I gave you something like the derivative of natural log of 2x, well, the derivative of 2x is 2 over 2x, which reduces down to 1 over x. Here I have the natural log of x squared plus 1, so the derivative of the inside is 2x. On the bottom, I have x squared plus 1. Done. There's really nothing can reduce out of there. Now, if I gave you a problem like this, the derivative of x, natural log of x, okay, now we're talking about the product rule. This is two functions being multiplied together, so you have to go u is equal to x, u prime is equal to 1, v is equal to natural log of x, v prime is equal to 1 over x. Inside, natural log of x, plus outside. Well, x times 1 over x, isn't that just 1? That would be my derivative. Okay, so the derivative of natural logs is fairly easy. It's just u prime over u. However, you can do the chain rule. So if this is the natural log of x raised to the third power, again, chain rule says bring down to 3, leave the middle alone. Times the derivative of the middle. Well, the derivative of natural log of x is 1 over x. Okay, so natural log, the derivative of natural log, should not be real difficult. And here are now derivatives of bases other than e. So if you have the derivative of a to the x, that is equal to natural log of a times a to the x. Now these are ones that you don't run into these that often. I mean, these are problems that don't come up too often, but you might see them once in a while, so just so you know them. So let's say I gave you a problem like a to the 3x squared, and I want rid of this, okay? Well, the formula says It's just a natural log of a times a to the u. Well, that's this, isn't it? And then derivative of u. So then we have to take the derivative of u at the end. So the derivative of 3x squared is just 6x. So this is going to be a 3x squared times 6x. So it's basically just a plug and chug formula that you're gonna just in your values. And the natural log, or I'm sorry, this is not natural log. This is just a log when it's not base 10. So it's any log. So if I gave you log base 5 of, let's say, 3x squared, that is going to be 1 over natural log of a. So 1 over natural log of 5, because that's my a value, times u, which is 3x squared, times the derivative, which is 6x. That would go on top. Right? So here I have a couple examples. The derivative of 2x, well, we can use this one because it's just a x value. So my answer is just natural log of 2 times 2x. Done. If I had 2 to the 3x, well, now we have to use this one. So we have natural log of 2 times 2 to the 3x times the derivative of 3x, which is 3, then put it all together. We just end up with 3 natural log of 2 to the x. So these are ones that you don't see that often, but it's not bad to know them. Right? Because you might see them. It's not ones that we spend a lot of time with because there's not a lot of problems on the AP tests that deal with those. But those are the two formulas for a to the u and log base a of u. Any questions on those? How you would get the answer?
Should we memorize these for the AP test?
I would not. If you have a lot of room in your mind to memorize things, you could. I would say that you would probably see maybe one question like that. There's so many other things to memorize that these are probably not the formulas that I would memorize. I would put them on 3x5 cards, and if you see a question like that, at least you look back and see, oh, this is how I solve those types of problems. But that's probably not one that I would memorize. Just they don't come up that often, if at all. So here are all of the differential rules that you should know for tests, right? You've got the constant rule, you've got the product rule, the chain rule, you've got sum and difference rules, all of the derivatives of sine, cosine, tangent, cotangent. These are all of them. These are the ones that you should really know. I mean, obviously the chain rule and the power rule are the most important. All right. Let's go through some examples of problems that would be on the AP test. What would your answer be? Well, cosine 3x, sine 3x to the third power. All right, if I was going to do this one, I'm going to rewrite it. Okay, bring down the 4, leave the middle. Then I have to take the derivative in the middle, which is cosine of 3x. Derivative in the middle. Now I can multiply 3 and 4. So my answer is, I think it would be letter B. Is that right?
That's what I got. Yeah.
All right. How about this one? What is my answer? Six x squared times x to the third plus 1. Okay, so if I was going to do this problem, I'd bring down 2, leave the middle alone. The first power times the derivative of the middle, which gives me 6x squared x to the third plus 1. Letter E. Very nice. Caleb, it looks like you understand the chain rule. Here's a little bit harder of a problem. It says find an equation of a tangent line to the graph of y is equal to the natural log of x to the 10th power at the point 1, 0. Okay, so remember, in order to write an equation of a tangent line, we need point and slope. So we do have the point, we don't have the slope. So what is going to be my slope, and then what is going to be my equation? All right, Caleb has letter C for the answer. Let's take a look here. If I was going to take the derivative of this thing, it's u prime over u, so that's going to be 10x to 9th over x to the 10th. Kind of can reduce this down to 10 over x. So if I put 1 in for x, my slope is 10. So now I have y minus 0 is equal to 10x minus 1, which really 10 y minus 0 is just y. So I end up with y is equal to 10x minus 1. And that is letter C. Very good. So that is the chain rule. Oof. Now, just by looking at the answer, let me see. Oh, they want the double derivative. Oh, because the way they write it, it doesn't seem like that. Okay, so what is the second derivative of this function? Oh, I see where they get the plus sign and minus signs in this problem. All right, so this is a second derivative. So what is the second derivative of sine of 5x to the 6th power? All right, and I'll let you guys keep working. If I was going to do this problem, first derivative is going to be cosine. Let's see. Oh, that's where I was wondering if it was okay, because this is just cosine 5x to the 6th times the derivative middle, which would be 30x to the 5th. Okay, so now this is where it comes in, because now we have, this is a chain rule. So I'm just going to go u is equal to cosine 5x to the 6th. U prime is equal to, what is that going to be, negative sine 5x to the 6th times 30x. Oops, it's going to be 30x to the 5th. V is going to equal 30x to the 5th. V prime is going to be, what is that going to be, 150x to the 4th? Is that right? So the inside, so I've got 30x to the 5th times 30x to the 5th, which is 900x to the 10th. That takes care of that and that, but I still have that negative sign, okay? And I don't know how they put it behind, so I'll just put negative 5x to the 6th plus, and then outside, so that's cosine and 150, so I'm going to go 150x to the 4th cosine 5x to the 6th. Phew. All right, so let's see here. So I've got negative 900x to the 10th sine of 5x, so that's okay there. And then 150x to the 4th cosine, that looks good there. So I do agree that letter E would be the correct answer. Kind of a crazy looking derivative. I'd hate to have to plug a number in there to come up with a slope, but that should be my second derivative there. I guess it wouldn't be the slope, it would be the acceleration, because it's second derivative. All right. What is my derivative? This goes back to last week. This is straight out product rule. But you do have to remember tangent, the derivative of tangent. All right. So in this problem, again, product rule, u is equal to x to the 5th. U prime is equal to 5x to the 4th. V is equal to tangent of x. V prime is equal to secant squared of x. Inside, 5x to the 4th. Tangent of x plus outside. Let's go x to the 5th secant squared of x. And that looks like letter E is correct. All right, any questions on the chain rule, product rule, quotient rule? All right. Henry, you've signed up for the College Board class, correct? Can I ask you to go into the College Board site right now? And Caleb, I'd like you to go back in there also. I've got to figure out what's not going right. All right. Oh, I wish I could see your guys' screen because that would help out immensely. Maybe I'll share my screen and then we can talk about it. Okay. So I'm going to share my screen here. Okay. Caleb, can you see the, I should turn this off because I closed preview. Okay. So Caleb, can you see my screen?
Yep.
Okay. Do you have, when you're in the College Board site, do you have a bunch of this stuff at the top where it says home and all that?
It's not exactly the same, but I clicked my AP, which got me to the
Okay.
class list, which looked a little bit like the lower part of your screen.
Okay. Do you see where it says week 7 practice? Do you have that?
Not really, no. It's just a list of topics. It's everything
Okay.
under weeks, like Unit 1 progress.
So you don't have the week 7 practice because that's the one that I created. All right. So I'm wondering why it's not showing up for you guys.
I have that.
You do have week 7 practice?
It says assignments week 7 practice, and then if I click on it, oh, it's loading. Yeah, I can see it. I can fill that out. It says week 7 practice, and I can fill stuff out.
Oh, awesome. So let me click on it. Okay. So do you see this is your first problem?
Yep, that's my first problem.
Awesome. All right, Caleb. Now we have to figure out why you're not seeing it. So Henry, you can see that. So what screen, obviously you guys don't have the same screen because I'm a teacher and I have teacher access here. So what screen are you, how did you get to where you are, Henry?
And text me a picture of your screen.
I can just send you the link, actually.
So did you just, let's see here. So I'm going to view progress. So it says that, so now it says that it's in progress, that Henry, you are in progress. So that, awesome, because I can see when a student opens it and when they start working on it, oh, this is a really an amazing site, except I don't know how to use it just of yet, everything. But if I can assign practices out here, because those practices are pretty amazing. I mean, they're much more like the AP questions than the Khan Academy is. And you guys have like you can do you can go into any unit and take any test and quiz, but the only ones that I want to see is the ones that I assign right now, but I'll be assigning more out of here. But this is pretty cool. The only thing is, I don't know how to tell you guys where to go. So Henry, can you click on home for me for 1 second? Up at, just click on home and see what it goes to.
I don't have that button. It just says, it says my AP.
Okay.
And
And then right away,
this-
does it say class progress?
yeah, it shows my it just shows the screen that I'm on right now. It just shows what week it is and then my AP classroom.
Could you take a screenshot of that and send it to me?
Yeah.
So that's what you get when you first log in?
No, I had to do some fiddling with it actually. It's let me just open a tab. Hold on. So I went to College Board or AP Central.
You have to go to the website, then go to AP, then go to AP Classroom or My AP.
See, I went to apstudents.com/.collegeboard .org, and that's just this. This is the first screen that comes up.
Yeah.
So the link that I sent you, Caleb, that's how I get to mine. So whenever I open it, that's what it is.
Can you
Yeah,
send
Henry,
me
does your class list thing look exactly like mine?
How do you
Like,
guys know which one you're looking at?
I texted Henry a picture of my
Okay.
screen.
Gotcha.
Mine still just has the list of all the units and 0 assignments to complete.
And I don't have it. So yours, you have Unit 1 progress check. Oh, I see. So yours has units and then Unit 1, Unit 2, Unit 3, Unit 4, Unit 5, all that?
Yeah, Unit 1, Part A, Unit 1, Part B. It doesn't. Yeah.
Okay, so I don't see that. I have a unit, like Unit 1, if I click on it, then it has like an introduction to calculus, defining limits, estimating limits. I wish I could see your screen so I know what you guys are seeing. But since Henry can get at the week number 7 practice, that at least is good news to me because I know I created it and I can see when I click on it, it tells me every student that it is assigned to, and it's assigned to everybody that's signed up so far for class. So I'm thinking I did it right.
Oh, is it called Week 7 practice?
Yes.
Okay. So I went to all my assignments, and then it's listed as the very last assignment.
Okay,
So,
now.
I don't know why, but it just wasn't on that home screen. So I got it now.
Okay. Can you tell me how you did that again so I can make up some? So what did you have to type?
So I was on the My AP, then it listed some assignments, and I clicked full assignment list.
Okay.
Then it brought me to a new page, and then I scrolled all the way to the bottom, looking through the assignments, and it's at the very bottom.
Interesting.
It
Henry,
still doesn't say that I've really been like assigned that though. It just gives it as an option.
Can you click on it?
I clicked begin.
Okay. Now, I'm just trying to get to the point where I can see who's logged in and not. Because before I could tell that Henry had opened it. No. Okay, viewing progress. Yes, now I show that you, Caleb, have opened it. Excellent. So
Awesome.
all right. So this is how we're going to do our practice next week. It's going to be on this website. So I mean, obviously, you guys can take it right now. They're much more difficult than the Khan Academy ones. They're pretty cool, I think. This website really has a lot of cool stuff for you guys. Hopefully, we can get use it more often this year. I just have to get used to using it. All right. Do you guys have any questions for me today before we leave?
No, that's it. Thank you, Mr. Shanklin.
All right. You guys have a great week. And
Yeah,
Caleb, I
thank
see
you.
that you emailed me your work, so I will get looking at that real quick, okay?